Hi guys, you probably noticed that this is 7.6. I'm going to skip over 7.5, save that for tomorrow. I think it makes more sense with me being gone and with the worksheet that you just got done doing. So hopefully you just got done correcting the foiling specials with Mrs. Cox. And there was a couple things I wanted you to notice on those. If you looked at problems 2, 4, 6, 7, 9, 11, you should have noticed that those were the exact same thing multiplied by itself twice. So maybe something like 2x plus 5 times 2x plus 5. And when it is a perfect square, there's ways that we can break that down easy. These two methods are really just shortcuts. We could get around them different ways, but this is certainly the easiest way. If we catch on to this trick, we can get there a lot faster by noticing that's a perfect square triangle. The other ones, so problems 1, 3, 5, 8, 10, and 12, those would be difference of squares. Hopefully you noticed that it was the same thing, but one had a plus sign, one had a minus sign. And that was a little bit easier to notice. Hopefully you noticed that every time you had one of those, the middle term completely disappeared and you were only left with 2 terms. So we're going to know some tricks about these, try to factor them, and that's what we got going on for today. So perfect square trinomial would be something times itself twice. So right here we got a plus b times a plus b, or a minus b times a minus b. So for example, this would be something like 2x plus 5 times 2x plus 5. And if we multiply that out, this right here would give us 4x squared. That would give us 10x. This would give us 10x. This would give us 25. So when we combine our like terms, we get 4x squared plus 20x plus 5. No, 25, sorry. So here is what hopefully we noticed. This is a little bit harder to see, but what we can see quite easily is that this first term is always the square of this. 2 times 2 is 4, x times x is x squared, and that should make sense because it's always the first thing multiplied right here. The last term is always the square of this, which again should make sense because it's always the last term, which is 5 times 5. The middle one is a little bit harder to notice, but what you can notice about that is that every time it is just 2 times 5 doubled. Because right here we do 2 times 5 and then we do 2 times 5 again. So we got 2 times 5 twice. So when we put those together, it doubles to give us 20. So if we get really good at building those up and we can notice these things, then we can break them down pretty easy. So here are the steps to doing this. You're going to check 4 things every time. So I want you to pause the video right now and I want you to write these down in your notes. You're going to want to look at your notes first couple of problems you do, and you're definitely going to want to look back at this on Friday when you do a review. So pause and write these down. Okay, so let's show you what I'm actually talking about. Here's what we're talking about. So, is the first term a perfect square? What is the square root? So if we look at this problem right here, 36x squared is the first term. Is it a perfect square? Yes. The square root is just a plain old 6x. Okay? So step number 1, yes, done, check, it worked. Step number 2, is the third term a perfect square, and what is the square root of that? 16 is definitely a perfect square, square root is 4. So yes, done, check, perfect square. Third one, is the middle term, and this is where the harder thing to notice. Remember, the first term was always just this squared, the last term was always this squared. You notice that the first term is always these two multiplied together and doubled. So that is our test. It has to pass that test. So if I multiply these two together, I get 24. So 6 times 4 equals 24. When I double that, it equals 48. Does that equal the middle term? And there's an important note right here. Ignore the sign. We're not worried about if the sign is the same. We just want to know this is... This is 48. Is that also 48? And the answer is yes. So it passes that. So we pass all 3. So if you answer yes to all 3 questions, then you factor it like this. So you take the square root of the first term, that's this right here. You take the square root of the last term, that's this right here. You take the sign of the middle term. So this is when you're going to look at this sign. If this is a plus sign, you put a plus here. If the minus sign, you put a minus. You wrap it in parentheses, and you call it a perfect square. And as always, how do you check your answer? Well, you could FOIL it out. If we did 6x plus 4 times 6x plus 4, we would get 36x squared. 36x squared. We would get 24x. We would get 24x again. And we would get 16. And if we put those two together, we would get that 48x. So this is what we're going to do every time. So we'll do several examples. You can pause on any one of these examples. We'll do a couple together, and then I would pause it, try the rest, and then you can go back and look at the answers. So this is exactly how your homework's going to look. It's how your quiz is going to look, how your test is going to look. It says determine if each is a perfect square trinomial. If so, factor it. If no, explain why. So you're going to do the test. So first, is that a perfect square? Yes. Is this a perfect square? Yes. Then if I multiply these two together, I get 24. If I double it, I get 48. That does not equal 15. So you're going to say, is it a perfect square trinomial? No. Why not? Because 3 times 8, when I double it, does not equal 15. We're done. Can't do any more. Okay, let's do this one over here. Is x squared a perfect square? Yes, it is. The square root is x. Is 4 a perfect square? Yes, it is. Square root is 2. When I multiply those two together, I get 2x. When I double it, I get 4x. That is this. So if the answer is yes, take the sign right here, grab these in parentheses, and call it a square. Is this a perfect square? Yes. Is this a perfect square? Yes. If I multiply those two together, I get 45. When I double it, I get 90. So I passed all 3 tests. Take this sign, grab it in parentheses, call it a square. The square root of that is x. The square root of that is 7. 7 times x is 7x. I double it, I get 14. So I passed the test. So I took this sign, square root of this is 6x. Square root of this is nothing. This is not a perfect square. So you're done. So is this a perfect square trinomial? No. 14 is not a perfect square. Square root of this. What is the square root of something? Okay, think about how we get to x to the 4. X to the 4 is x2 times x2. Because remember, you add the exponent. So the square root of this is 3x squared. The square root of this is 2. I multiply those two together and I double them and I get 12. That is not this. So we're going to say no. 3 times 2 and then double it is not 6. Okay? You can do a story problem here. It says you've got a rectangular piece of cloth that must be cut to make a tablecloth. This is the area. The area of something is always length times width. So it says find the dimensions. So basically we want to undo this. We want to factor it. And because we are in perfect square trinomials, let's check and see if this is a perfect square. So the square root of 16x squared is 4x. Square root of 9 is 3. Multiply those together, I get 12. I double it, I get 24. So I take this sign, call it a square. So it says, write an expression for the perimeter of the cloth. So if this is 4x minus 3, and this is 4x minus 3, if I want to do the perimeter, this is 4x minus 3. If I do the perimeter, 4x plus 4x plus 4x plus 4x gives me 16x. Minus minus 3 minus 3 minus 3 minus 3 is a minus 12. Find the perimeter when x equals 11. So if I plug in 11 right here, 16 times 11 minus 12, and you can do that right here. Okay? So let's move on to difference of squares. Difference of squares, you have one thing with a plus sign, one thing with a minus sign. And what you should have noticed, so we'll use the same example as before, 2x plus 5, 2x minus 5. This right here is always going to give me the 4x squared. This is going to give me a minus 10x. This is going to give me a plus 10x. This is going to give me a minus 25. So, if I combine like terms, I have 4x squared minus 25. So what you should have noticed, this is a perfect square. It's always just 2 times 2. The first two things multiply together. This is a perfect square. Ignoring the minus sign. It's just the 5 times 5. These two always disappear, because one is always a plus, one's always a minus. So that middle term is completely gone. So here's our checks. This is much easier. Here's our checks for a difference of squares. So pause this and write down these into your notes. There are two things when you hear difference of squares that I want to bring in your head. First thing, difference of squares, the word difference means to subtract. This must be a minus sign, else you can't do the problem. Second thing, when you think difference of squares, I want you to think different. So we're going to have two parentheses with two different signs. Okay? So here's your test. This is the first term, a perfect square. What's the square root? Yes. 3x squared. It's the last term. A perfect square, and what is the square root? Yes, the square root of 81 is 9. And if I do y3 times y3 and add the exponents, I get y6. This one's really complicated. Is there a minus sign in between? Yes, there is. So if there is a minus sign in between, we write it twice, one with a minus sign, one with a plus sign. And that's going to give us the first one as a square, the last one as a square, and the middle two will disappear. So, difference of squares, difference, you have a minus sign, and then you also think different. Two different parentheses, one with a minus, one with a plus. So go through, try these problems, pause it, and then I'll give you the answers real quick. So first question, is this a perfect square? No, it's not. 3 is not a perfect square, so you're done. You say no. 3 is not a perfect square. Is this a perfect square? Yes. 1 times 1 is 1. 2x times 2x is 4x squared. And yes, there is a minus sign in between. So 1 with a minus. 100 is a perfect square, but is x cubed a perfect square? Keep in mind you have to add the exponents. So the only possible way it's ever going to be a perfect square is if it's even, because I'd have to multiply x to the 1.5 times x to the 1.5, and we don't do that. So x cubed is not a perfect square, so no. X cubed is not a perfect square. P to the 8th. Yes, that is a perfect square. You could do P4 times P4. 7 cubed 6, or 7 cubed 3. You could do Q3 times Q3, Q6. Yes, there is a minus sign in between, so 1 with a minus, 1 with a plus. X4 is a perfect square. 25x6 is a perfect square. There is a minus sign in between, so 1 with a minus, yes, this is a perfect square. No, this is not a perfect square. There is no way I'm going to multiply two things together to get y to the 5th. It would have to be y2 times y3, and that does not work. So we say no, because y5 is not perfect. And I think that is all you need to know. That is the end of the lesson. So try your worksheet. Go back to this, watch it again if you have any questions, and hopefully you're all set. Have a good day.